Welcome to Portland Technical's video on basic DVOM operation. In this video, we're going to be taking a look at voltage tests. First of all, before we get into the DVOM, let's take a look at what voltage is. To relate this to something we're familiar with, think of water flowing through a pipe. If it's going to flow through a pipe, there's one thing that we need, and that is pressure. If we don't have that pressure, then the water will be stagnant. It's very similar in electricity. In order to move electrons through a conductor, we need to have pressure. And that's exactly what voltage is. Electrical pressure that moves current through a conductor, such as a wire. Now, when it comes to measuring voltage, that's where the DVOM comes into play. First of all, DVOM stands for digital volt-ohm-meter. It measures voltage potential in a safe and accurate manner and will give you a numeric value for the reading of the voltage. And it has the ability to measure very large voltages all the way down to voltages less than 1 volt. So, since we have such a wide range of voltage ability, there's a couple of things we need to pay attention to on the DVOM, and that is the two indicators that you see here on the screen. MV for millivolts and V for voltage. These two qualifiers will be on the right hand bottom edge of the screen to show you exactly what we're reading. Now, what is the relationship between millivolts and voltage? Well, here's the equation. 1000 millivolts equals 1 volt of electricity. Let's dive into this a little bit deeper. Now think of counting. Once we get over 1000, we get a comma there to indicate the difference. Much like that millivoltage, once we reach 1000 millivolts, we go into volts. And so in this case, we had 1.982 volts, or in other words, 1 volt, and then 982 millivolts. Okay, so let's take a look at this a little bit further. What if my screen simply said 85? Well, 85 MV or millivolts, that would equal 0.085 volts. Since 1000 millivolts equals 1 volt, if we take that decimal point from right here and move it over 3 spots, that would equal 0.085 volts. Okay, let's take a look at it the opposite direction now. What if I had 5 volts? Well, in this case, if I were to convert that to millivoltage, I'd take my decimal point, which would be right here, and move it over 3 spaces to equal 5,000 millivolts. Hopefully this makes sense to you. But before we get reading any voltage readings, just remember to pay attention to whether it says MV or V. Okay, so let's see how to hook up the DVOM. There's 2 ports, the COM port and the voltage port. Red is going to represent positive, and then black is going to represent negative. And we're going to use these leads in correlation with positive and negative, similar to a battery, how voltage and current wants to flow. So hooking these 2 up, there we go. Now let's take a closer look at those ports. The black port, where the black or negative lead went, says COM for common ground. The voltage port is red and is indicated so forth. The other 2 ports are used for amperage readings. We won't use those here. Milliamps and amps, that's for a different type of test. There are 3 settings that we can have on the DVOM for voltage: AC voltage, DC voltage or direct current, and millivoltage in direct current. We're going to be using DC voltage. This is going to be the most common one for us to choose. Let's look at the display now. Notice the V for voltage And here is direct voltage. And notice it says manual 6. This is going to read up to 6 volts in this range. Here it says 60, so now it's a range of 60. Once more, it's 600. And then to its maximum, 1000. Now, it's going to auto range for you, but we can put it in these ranges as well. Okay, let's move on from here. We're going to use this simple circuit and this power supply to take a look at doing our first voltage measurements. Okay, so let's take a look at our circuit itself. Zoom in here a little bit. And we've got ourselves a fuse, a bulb, and a switch. Let's take a closer look. Okay, so power is going to be coming from here and is going to be across this entire row of red wires. They're going to have the wire that comes down to the fuse, goes through the fuse, then carries on this wire to the light bulb itself. Voltage will push current through that bulb and then down the wire to ground, through this switch, and then to finishing to ground, where it goes right back to the power supply on the black wire. Now, before we get testing on our circuit, let's take a look at the 3 different types of voltage tests we can do. First of all, would be source voltage, or in other words, what is the voltage at the source? So in other words, we're checking the battery. Next would be available voltage. Here we're going to take the black lead of our multimeter and put it on a known good ground, and then take our red lead and put it at the point that we want to know what the available voltage is. So I can check anywhere, on a connector, on a component, whatever the case may be. Then the third type is going to be voltage drop. Now here I'm going to use the 2 leads of the multimeter, and in essence the easiest way for me to remember what I'm doing in a voltage drop test is I want to know how much voltage is being used from the red lead to the black lead. This is going to be a way that we can go ahead and narrow down where our problem is on a faulty circuit. Okay, let's jump into it. Let's start by checking source voltage. Turn my circuit on, and we're going to go to the source. And that's going to be represented by the red connectors at the top and the black connectors on the bottom. So I'm going to put black lead on the ground side, red lead on the power side, and we can see at the source I have 13.97 volts. Okay, let's go on to our next test. Next comes available voltage. Now, leaving my black lead on my known good ground, I'm going to go to a point in the circuit that I want to know where it's at. I'm going to choose right before the bulb itself. So now I've plumbed into the connector right by the bulb, my ground is good, and I can see I have 13.96 volts. So let's check out voltage drop now. Now remember, voltage drop is going to be the voltage I lose from the red lead to the black lead. So I'm going to be just measuring a small portion of the circuit and see how much voltage is dropped. Now, I'm going to first check the voltage drop over the bulb. This is the load, so most of the voltage should drop over it. And we can see that we dropped 13.9 volts. Okay, let's go ahead and check what we have dropped over the rest of the circuit on the ground side. Now I want to check from the bulb all the way to ground. All I have to do that is with my circuit operating, I'm going to put the red lead on the ground side of the bulb and then put my black lead where it grounds. And now it's reading 0.04 volts, or in other words 40 millivolts. That's how much is dropped on the ground side of the circuit. One very important thing is to put a battery charger on the vehicle that you're working on every single time you're doing voltage checks, because it's going to require the key to be on, which is going to drain the battery down. So keep it consistent, use a battery charger. Okay, it's game time. Let's try this on a real vehicle. Turn my multimeter on, go ahead and remove the battery plug for our source voltage check. Black lead on the negative side of the battery, red lead on the positive side, 12.29 volts. Okay, I got my reference for what for checking a circuit. For available voltage, I'm going to go ahead and just take the black lead off of my multimeter, and I'm going to replace it with an alligator clip. Some DVOMs have this feature, and it really works out well. Now, I'm going to clip it right to the negative battery cable. This way I know I'm going to have a good ground. However, I could use another ground. So now I'm going to go ahead and check available voltage at the circuit fuse. I'm going to use this 7.5 amp EFI1 fuse. Looks like I got 12.29, same as source. We're doing good. Just so you can see what I was doing, here I am zoomed in. Now remember, my black lead of my multimeter is on the negative side of the battery. So here I am with the red lead, and I'm just going right to the tang on the fuse to get my reading. Okay, and I can check the other side of the fuse too. This will tell me whether the fuse is good or not if I see voltage on both sides. Alright, let's move on. Okay, so let's do an available voltage and a voltage drop test. Let's pretend on this mirror assembly that the left-hand mirror, the up position, does not work. So I've already looked at the EWD to go ahead and see which wires I'm going to check. So I'm just going to get my multimeter here in place and prepare to do my checks. Now I'm going to use some special leads in this scenario. These leads have some back probe pins so I can probe the back of the connectors. So I'm going to go to the wire that actually supplies power to the motor for the remote mirrors, and then I'm going to go to the door striker with my black lead and see what I have for available voltage. Looks like I have 11.95 volts. Okay, now if it's not operating, I'm going to do a voltage drop test over the motor itself. I happen to know where the wire comes out to ground, actuate it, and it looks like I'm dropping 10.5 volts that way. So, no operation, but yet I have a complete circuit, and I'm dropping voltage over the motor. So it looks like I might have a bad motor in this scenario. Here's a closer look at the connector I was going ahead and back probing. There's the two wires, and let me show you exactly what I was doing. Using my very thin 0.25 diameter back probe pins, I'm just moving into the connector to the side of the wire to where I'm making contact with the metal terminal. Do the same for the ground side, and there you go. Okay, so for a short review, remember those voltage tests were source voltage, or in other words, the voltage at the source, in other words, the battery. Available voltage, this is where you're checking the voltage at a given point in the circuit, having the black lead on a known good ground. Then last but not least, a voltage drop. Now, the way that I remember that is that I am actually checking to see how much voltage is lost from the red lead to the black lead in the circuit itself. It's a good way to narrow down exactly where your problem is. Okay, I only have a short amount of time to be able to explain these, and I certainly can't answer any questions in a video. So for further questions, contact your FTS or STS for further information, other questions, or feel free to drop some comments or questions in the video below. Alright, thanks for your time. Have a good one.